Everyone, have you ever actually stopped to think about the invisible physical process that literally allows us to see the world around us? I mean, it feels totally automatic, right? But it's actually grounded in some incredibly elegant physics. So today, we're unlocking the mechanics of that very process. We are diving into the anatomy of reflection, or as we call it in Marathi, prakashatse paravartan.
Here is our quick roadmap for this explainer. We'll start with the darkroom observation, cover the core concepts of light, jump into the laws of reflection, compare smooth versus rough surfaces, and finish up with a mathematical application.
All right, part 1. The darkroom observation. आपण वस्तू कशी पाहतो?
So, picture this. You're in your bedroom at night, you flip the main light switch off, and boom, everything around you instantly vanishes. You flip it back on, and all your stuff reappears. It's a super basic observation, sure, but it proves a crucial point. We can literally only see objects when light from a source bounces off of them and physically enters our eyes.
This whole bouncing mechanism, that is what we formally define as the reflection of light, or prakasha ke paravartan. Put simply, when light rays hit a surface, their direction shifts and they bounce right back. And honestly, that simple bounce is the fundamental reason we can see anything that doesn't glow on its own.
Moving right along to Section 2, Core Concepts of Light, Prakashache Paravartan Ani Sankalpana.
Now, what's really interesting about this visual is how it breaks down the anatomy of a single beam of light. See that incoming red arrow? We call that the incident ray. This is the light heading straight toward our surface. It hits exactly at the point of incidence. Now notice that perfectly straight vertical blue line standing at exactly 90 degrees right where it hits? That is the normal, which acts as our invisible reference line. And finally, follow that green arrow bouncing outward away from the surface. That is our reflected ray. It's basically a geometric dance.
Section 3. The Laws of Reflection. Prakashatsa Paravartanatse Niyam. Okay, so this brings us to the absolute golden rule of this whole process. First, you've got to identify the angle between that incoming ray and our normal line. We call that the angle of incidence, or angle I. Next, find the angle between the bouncing ray and the normal. That's the angle of reflection, or angle R. Here is the absolute unbreakable rule of physics. Angle I and angle R are always equal. It is literally a perfectly symmetrical law, no exceptions.
Let's look at Section 4. Smooth versus rough surfaces, niyamit and unniyamit paravartan.
So if the law is absolute, why do different materials look so totally different to us? Well, think about a flat mirror on the left side here. That's regular reflection, or nimit paravartan. The surface is perfectly smooth, so all those incoming parallel light rays hit it, follow the exact same angles, and bounce back perfectly parallel. The image stays completely intact. But on the right side, what about a piece of rough cardboard? That's irregular reflection, or animit paravartan. Because the surface is bumpy at a microscopic level, that 90-degree normal line points in a totally different direction for every single tiny bump. So the bouncing light just scatters everywhere, totally scrambling the image.
Finally, Section 5, Mathematical Application. Ganitatil upyojan.
Let's actually put this into practice and walk through the math together. Imagine a flat mirror. Step 1 gives us our setup. A ray of light hits the mirror, creating a 35-degree angle right against the physical surface of the mirror itself. Okay, step 2. Remember our normal reference line that always stands straight up at exactly 90 degrees to the surface. So, for step 3, we need to do a little quick math to find our actual angle of incidence. We just take that total 90-degree angle of the normal, subtract the 35 degrees from the flat surface, and we're left with 55 degrees. That 55 degrees is our angle of incidence. Finally, step 4, we apply our golden rule. Since the angle of incidence is 55 degrees, the angle of reflection has to be exactly 55 degrees too. It's incredibly predictable, and honestly, just super elegant.
So, as we wrap up this explainer, I want to leave you with this question to chew on. How would the world look if there was absolutely no reflection of light? I mean, without this simple bouncing mechanism, literally no object could transmit visual info back to our brains. Unless you were staring directly into a light bulb or the sun, our entire world would be pitch black. Every single color, shape, and face that you see every single day, it's all just a masterpiece painted by billions of perfectly angled, bouncing light rays. Pretty mind-blowing when you think about it like that, right? Thanks for joining me today.